Okay, it sounds like you hear me well. I'm Ori, team lead for Cairo1 team at Starkware. I tend to speak very, very fast. Please stop me if I actually do that. I will try to hold myself. Feel free to raise your hand with question and anything. I'm here to answer things. I don't really care about slides generally. So if for some reason we dive into a bit of another discussion, that's fine with me. But the main subject is Cairo1. So basically, we're going to speak about three things today. What is Cairo0, which is the basic provable programming language at Starknet. Cairo1, which is the new language, which adds robustness and ergonomics to the actual basic provable language, and Starknet, which is how we actually use it, or how we actually plan to use it for layer 2, L2 to Ethereum. So, section number 1. What is Cairo? Why would it be useful for something? Let's assume we want to explore space. We want to save fuel, so we need to find the best launch window and the best trajectory for our spaceship. So we create the best algorithm in Rust to run this program, and that's it. All is good. But the execution of this specific algorithm requires a supercomputer. And we're too poor for it, and we don't have a supercomputer. Only one country on the planet has this sort of supercomputer, and we don't trust it. What can we do? So we pay that country some amount of money, so they run this for us. But we can't actually trust them, because maybe they just give us not the best route, and we'll just waste a lot of money over this launch. So we can know either the company tries to cheat us, or they're just they're just not really good at their job, they malfunction. So how can we make sure they actually ran whatever we wanted them to run? We can't this way. But if we write our algorithm, instead of in Rust, we write it in Cairo, we can ask them to execute the program, generate the result, plus a proof that they actually executed this specific program, and then we can trust it by just running the verification. Sorry? So they would not be able to prove this specific program if their execution was false in any way, shape, or form. So only a regular computer can, as this Einstein laptop sees, it can show that whatever proof whatever execution performed by the supercomputer was actually correct. So what do we need for this? Generally, we need a Cairo program. We compile the Cairo VM to a Cairo VM bytecode. We send that to the supercomputer. The supercomputer runs the Cairo VM, returns the result, and creates a trace, send it to a prover that actually generates a proof, and we can verify the result. So generally, what we achieve through Cairo, or Cairo0, or Chasm, all used interchangeably, we can create provable programs, and it creates a proof along the result, and we can verify it in logarithmic time without re-execution of the actual program. That's the general idea of Cairo0. And since it's much, much cheaper, it can be done without a supercomputer by a cheap computer. We'll get to how that is in Starknet in the third section. So what do we achieve by Cairo1? why not just use Cairo0? Okay, so the additional things we have in Cairo1 is, first of all, it's a more high-level language. No, in Cairo0, there's a lot of stuff that are very specific to the Cairo virtual machine that we need to actually prove. But it gives very similar power to the things we got in Cairo0. It's open source. You can read the code. You can see the weird hours I submit PRs, so it's all good. And there's a lot of features coming up. There are, if anyone's interested, there's loops now in the head in the main. So I know a lot of people wanted that in Cairo0. And a lot more features to come. Okay. Generally, what we achieve through Cairo1, the purpose is to create Cairo0 code or CASM code, which is the provable code. But over it, we want to add safety. We'll touch upon it in a second, and ergonomics. For safety purposes, we have an intermediate language, intermediate representation called Sierra, which is a more complex bytecode, but it's a fully typed bytecode. What I mean by a fully typed bytecode, it adds a layer that everything is typed in a way, and using this type system, we can promise a lot of stuff about the status of the run. So we can know that, for example, every dictionary, which is the only sort of actual mutable object in Cairo0, we can show that every dictionary is actually squashed in the end, which means it is actually valid, because a dictionary in Cairo0 is not valid unless you squash it. And for example, arrays, if we push into an array and copy it and push into the two variables, in Cairo0 it would have been possible, but it would have been illegal since we have immutable memory in Cairo. So basically it would have meant that we've written two different values to the same location, which would have made code that is not provable. And so on, and other sorts of safety that can be promised by the type system. Since you cannot duplicate an array in Sierra, you won't be able to write code that is not provable. So Sierra makes sure that every run would be valid, while Cairo0 does not promise that. Ergonomics, we developed Cairo1 with a lot of modern sensibility about programming language development. So it actually works in layers. We start with a basic syntax. We parse it into a syntax tree. We use the syntax tree to create a semantic model, and everything is, and then we can do borrow checking and auto addition of codes, and for example, and things like that. Unlike Cairo0, which basically started as an assembly, and then we added features upon it until it became a sort of a high-level language. It all is basically in the same thing. Here is completely split into layers, very adaptive to adding analyzers and these sort of things. So it would enables a lot of extensions and so on. I even know that since we have some sort of procedural macros, I know some teams just added more procedural macros and basically added a flavor of their own to the compiler, which definitely would have been as possible in Cairo0. Yeah, so Cairo1, if I summarize here, basically enables us to prove more, not just proving that a program succeeded, also proving that it failed, and is more ergonomic. Okay. So the best of all world, ergonomics. We took a lot of inspiration of Rust, and purpose, just making everything provable. So having Cairo0 and Cairo1, we now can use Starknet. What is Starknet? If we come back to the example, our country wants to do the launch codes. We now know that the best route is 42, and we verified it because we trusted the rival country because they ran our code. But the third country does not trust us, so they cannot know that the actual execution is valid. They need to run the verification themselves, for example. So what does Alice need to trust? It means that she needs to know what was the actual Cairo program. If you know what was the actual Cairo program, she could verify it herself. So how do we convince strangers using the original chasm that we got the Cairo VM bytecode? So they can just compile the bytecode and execute it, know that the result is 42, and they don't trust them, so they can do the proof and everything else. So here we have all the different parts of Starknet generally. So since after executing, we also added a proof, and we run the verification on Ethereum, everyone can know that, well, that the fact that we've written in the registry on Ethereum are correct. So we just need to make the program public. So we deploy the program on Ethereum. Everyone can access it now, and the Starknet core has the program, and everyone can verify the proof that anyone is basically the single processor which is called Ethereum. And if we want to outsource the execution itself, because here every laptop actually performed the execution, but now we can execute the program on the sequencer on Starknet. It creates an execution trace, send it to Sharp, and on the Starknet core, we can write the entire verification as well as the actual result. And everyone can be convinced of that fact. So generally, what happens in Starknet is if we get out of the specific calculation example and go to transactions, the sequencer just gets a set of transactions, creates an execution trace for all. The execution trace and the state diff, because the set of transaction just changes the Starknet state. It can write the state diff into Ethereum and ask the prover to prove the execution trace. And we can also now write the verification of the proof, run the verification of the proof in Ethereum. And having both, everyone can be convinced that the state diff is valid. And the full node can read this data. And also can provide knowledge about pending blocks, but this is up to the user to decide of how trusting it is of the Starknet state. So all the modules are. It's the sequencer that validates, executes, and bundles the transactions, the prover that creates the proofs, a verifier that is a Solidity contract that verifies Stark, the fact registry is just a smart contract that knows all the verifications that were valid, and the core, which actually contains the state of Starknet, and the full node, which can provide data just for the L2 apps, because somehow we need to access the data. That's all. So if we summarize there, why do we want to use Starknet? We can use the provable execution and transparency and the open lab. We can just prove everything and to anyone. Execution, proof generation, and verification is open. It's a service for everyone. And we can use Ethereum and get all the promises we have for Ethereum for security and availability. Execute once, verify everywhere, which is the magic there. About Sierra, if we go back, what Sierra added here is now, since now, Starknet, starting from a few months, would not actually accept Cairo0 based contracts, but only Sierra-based contracts. What it means is that every contract we would know for a fact that it would never fail. And if it fails in a provable way. So this way, every contract that we ever have can never actually block us. Since everything is provable, even if someone sends me a failed transaction, I can still make them pay for it. I can still know and prove that this is what specifically caused by this transaction. While in Cairo0, if something failed, unless I do some other economic mechanism, I cannot actually prove to the user, look, I charge you because you actually took this amount of steps to execute. So that's another another thing we got to through the robustness I discussed earlier. And that's it. If you have any question, I'd be happy to answer. Okay. So, thank you very much.
Is there any questions from the audience?
Yes.
Sequencer and Starknet core are always interactive each other. Are there any intervals?
Could you please repeat that? Could you please repeat the question?
Sequencer and Starknet core on L1 are make interaction always. Or, I want to know there are any intervals, like a block time.
There are blocks. Each transaction is packed into blocks through the sequencer, and then sent to the prover to be proved, and the state diff. So the sequencer and the sequencer and what are interacting? I'm sorry. I don't think I understand the question.
I see. Thank you.
Can you repeat the question to him so that I can translate?
I see. シーケンサーとスタークネットコアは常に通信をしているのか知りたいです。シーケンサーとスタークネットコアは常に通信をしているか。
So the question is, Starknet core and sequencer already has a communication. Yeah.
So the communication is through them is the sequencer tells Starknet core the next state diff, as well as tell it to the full node, which reads the Starknet core.
So they have an interaction, right? Right now, at this moment. I think that's the question.
Do they have interaction? This is the interaction they have. Generally, the writing of the state diff, and the full node just knows to read the actual state to know if it's actually updated on L1.
Oh, okay, you're good.
And I see another question in the back.
Yeah, thanks for your talk. I would like to know how the Starknet architecture looks like, the infrastructure, so who runs the sequencer, the prover, also some clarification about the network as a whole, the full nodes and so on, and what are your plans ahead for the sequencer and so on.
So currently, this is the sequencer, prover, and full node are all run by Starknet, by Starkware. We do not want that to be the case. This is part of why a lot of it is being open sourced right now, as well as we're designing not exactly in my area, but we're designing what are the actual methods would be for having multiple sequencers that actually show the work, because in this space, we definitely don't want to have a single point of trust. There are algorithms being worked on in the company and out of it to trying to understand what would be the correct way to do it. But I can't share any algorithm because any algorithms about that because I definitely don't know them yet.
Good, thank you.
Store data or state on Ethereum, and what the EIP 4844 affects Starknet. Thank you.
What on Ethereum? Sorry.
The second question?
Oh, I think moving between the mic and non-mic, I got confused. Could you just repeat?
Oh, okay. My first question is that could you share more about how sequencer store the data or the state on Ethereum? And the second question is that there is a new EIP, the portal link sharding, and I'm wondering how this will affect the Starknet. Thank you.
So for the first question, on Ethereum, we store the actual state diff, which means we say what was the actual chain, the actual provable chain in the Merkle tree that represent the Patricia tree that represent the entire Starknet state. So we post the actual changes. I'm not exactly familiar with what exactly the changes, but definitely the Merkle root is definitely updated. I'm not sure about the paths themselves, but we can check it out because I'm not entirely sure. And you said something about updates in the prover, and I did not fully understand the second question.
Second part was about Prototype sharding 4844.
Oh,
If it affects the data store.
I'm not sure. I'm not that well versed in this part of the protocols.
Is there any other questions?
Okay, when I think you are transporting the architecture from Python to Rust, right?
Yeah. It's been rewritten from
yeah,
the sequencer is being rewritten in Rust. Yeah.
Right. I think I read some documentation about sequencer, and they said the sequencer will be decentralization. I want to know how to decentralize the sequencer.
That is a very good question. It has a technological question and an economics question about how do you actually do this. I know there is research on the subject. Noam Nissan, if some of you heard the name, is researching it at Starkware, but I don't really know the actual methods there.
Okay.
Because you need economics incentives for provers to prove. You need economic incentives for sequencers to not cheat. Yeah, all the blockchain problems are coming back.
Yeah. I'm very clear about that. Okay, thank you.
Yep. I think that's good.
Thank you very much.